Hello friends, so today I am going to discuss, there is a question from GATE 2024. If you see this question is from condensed matter physics with the subtopic of the superconductivity. Question is saying a material behave as a superconductor below a critical temperature Tc and a normal conductor above Tc. Alright? So, इस particular theory पर जाने से पहले, before going to the particular theory, I am going to tell you the basic concept of the superconductor. I am not going into deep very, but just giving you a brief introduction. Let's suppose there is a resistivity and there is a temperature on this axis. It has been seen that for certain temperature, if we reduce that temperature, the resistivity goes on decreasing. It is basically talking about the metal. But there is a certain limit of the temperature that's called the Tc, critical temperature. Below this temperature, it has been seen that the resistivity of certain material becomes perfectly zero. That means there is no resistivity below Tc. Okay? Alright? So this basically, this phenomena, this process is known as the superconductivity, and such materials which exhibit this phenomena is known as the superconductor. Okay? Now I am coming to this question. In this question it has been seen that a magnetic field B vector is Bz cap. B vector is equal to B in the Z direction is applied when temperature is greater than Tc. When temperature is greater than Tc, the material is then cooled below critical temperature in the presence of the magnetic field. Then which of the following figure represent the correct configuration of the magnetic field line? Guys, if you see clearly, it has been stated, or indirectly or directly you can say this question is from the Meissner effect. Okay? This is a Meissner effect problem. What is Meissner effect? I am going to tell you. Let's suppose this is a material. Initially there is a material, a metal. Okay? And here I am saying magnetic field is not zero. Basically I am applying the magnetic field. Okay? And here temperature is greater than critical temperature. If you see the critical temperature for the mercury, it is around 4.3 Kelvin. For the mercury, it is the critical temperature is around 4.3 Kelvin. Okay, so temperature is greater than certain critical temperature. Okay, then it has been observed that all the magnetic field lines are crossing through this material. All the field lines are crossing through this material. Okay. Now, as we start to decrease the temperature, or you can say as we start to approach the temperature, critical temperature, alright, it has been seen that above Tc that all the field lines are crossing through the material, but as we reach the critical temperature or below critical temperature, it has been observed that the field lines is going to be repelled. Basically what at the temperature is happening at temperature T less than critical temperature, alright, and it has been observed that all the field line basically repelled by this material. All the field lines repelled by this material, and we know that this property, the repulsion of the magnetic field lines by any material, this is a property of diamagnetic material. So it can be said that the superconductors are perfectly diamagnet in nature. Superconductor are perfectly diamagnet in nature, because diamagnetic material basically contains the property to repel the magnetic field lines, and also its susceptibility is negative. Both this property has been seen in the superconductors, that at the temperature greater than the critical temperature, all the field lines crossing through the materials, but as we reach the temperature below critical temperature, the field lines perfectly expelled by the material, and now this specimen, this material has been converted into the superconductor. So this is the Meissner effect, all right? This is the Meissner effect. Now, look at the graph. Look at the pictures. If you see the option number A, at the temperature greater than the critical temperature, all the field lines are crossing through this material. So this is the property of Meissner effect, which we have discussed right now. So I guess this option is correct. This question is a multiple selective question asked in the GATE exam. That means there is more than one option is correct. So option A is correct. Now, what about option B? Option B is saying temperature less than critical temperature, field lines crossing the material, but this is not true. This is not true. Because below the critical temperature, field lines expelled by the material or the specimen, which is satisfying the option number C. At the temperature less than the critical temperature, the field line expelled by the material, as it has been seen in option number C. Okay? All the field lines has been expelled at temperature less than the critical temperature. That means option C is also correct. Option D is saying the magnetic field lines are making a closed loop at the temperature less than the critical temperature is not going to be in the superconductor part. So option A and option C basically are correct option, and this is a question from multiple selective, so we can say that option A and C are correct. Okay, thank you so much.